Hey, good morning, YouTubers. Welcome back to the channel. If you haven't been here before, welcome for the first time. Don't forget to smash that like and subscribe button. The more subscribers I get, the more successful my YouTube career will be. And according to my 11 and 9-year-old, YouTubers are rich and they drive Lamborghinis and they get money in the mailbox. So I'm waiting for my millions any day now. So don't forget to like and subscribe. Alrighty, today we're getting started with the design project for our Welding Tech 1 class. And what I've got here are my pieces, which we'll talk about in a minute here. But we're going to start tacking these guys together. This one's going to be a bling bling diamond. So we've got to discuss how to get these parts put together to fabricate the shape. And there's some steps and things involved to doing this that will make a huge difference in the outcome of how good your project ends up looking when it's finished. Okay. First and foremost, rule number one when fabricating projects: do not weld it until the entire thing is tacked together. We are going to tack weld these. I'm going to put this piece to this piece, and I'm going to put just a tiny little tack. Well, maybe not super tiny, but I'm going to put a tack weld right here. So a little tack. And then I'm going to put a little tack on this side. And I am not, repeat this, I am not going to weld this joint. I say this with enthusiasm because I've done this long enough to know that at least a couple students in every class will tack those two and then just weld it out. And then what happens is this perfect angle that you had set here goes like this, or it twists out like this, or one side, this side here folds down, something gives, right? That's because when we weld things, we get what's referred to as distortion. And distortion is one of the biggest issues that we have in welding. Okay, there's a little video that I'll show you guys on distortion with a little cartoon character called Mr. Shrink. And Mr. Shrink shows us what happens when we weld things and how it works and how to counteract that. So the best way to counteract distortion is to have a good welding joint design. So for example, in this case here, what's going to happen is if I have this piece, and this is part of the reason that your projects are enclosed shapes, because it's much easier to control distortion on an enclosed shape. So these pieces that I'm going to weld here, as I make this weld across this corner right here, this piece is going to want to bend up. I'm going to weld the outside corner. The weld's going to want to bend up. So if I have this piece tacked to another piece that's also here, which is going to be tacked to, this isn't the best example to show you guys all of this, but this piece that will be tacked to the other piece here. In fact, you know what? Let me pause this for a second. Let me get a better example. Okay, I'm back with another example. This is a better one. This one's already been completed. Design project's already been tacked together, fully tacked, and then we welded it out. Okay, so this weld right here, pretty decent weld on there. Not bad weld quality, gas weld across there. When we make that weld, this angle right here is a nice 90-degree angle, I think. Oh yeah, pretty square, looks good, okay? So what happens is I tack this thing up 90 right here, and then if I make this weld, these two pieces are gonna go like this. No longer gonna be 90. It's just gonna spread wide open. Now that would then make putting on this rectangle that is 90 very, very difficult to get on there, because now I'd have to try to bend those pieces back. That's not going to work. And we're going to end up scrapping these two pieces that we welded together, and we wasted all the time of cutting them, cleaning them all up, getting them tacked, and then if you weld it, you're going to end up trashing it, because it's very difficult to fix after it's welded. To bend it, you're going to have to, it would take a lot of work and effort, and it's still never going to look right. So what we want to do instead is, what's going to prevent this edge from bending out is the fact that it's tacked to this piece down here that has this rectangle here that would then cause the whole thing to bend with this piece on it, except that it's tacked down here and up here and over here. So now as this piece wants to go, it can't, because it has forces that are occurred because it's all tacked together, right? Same thing goes this edge right here. When I weld that one, this piece is going to want to bend out. This piece would want to bend same way. Would want to the pieces. Anytime you make a weld, they want to pull apart. So this piece and this piece are going to want to spread apart, but they can't because it's tacked down here, which is tacked to this, which is tacked to this, which is tacked to that. So now as it tries to pull, it can't because those tacks are there holding it in place. All right, and that's really what we're after. We want to get this whole thing tacked together so that any weld I make this weld across here, this piece is going to try to pull. It can't because it's tacked down here on this corner and these corners that are holding it there, which are, of course, then tacked to these edges and all the way around, okay? I hope that makes sense, and I hope that I can get that through your head. Before you weld anything, you need to tack pieces together, and this goes throughout anything you're going to build. You want to make a barbecue, you want to make a go-kart, we're going to tack together pieces on that frame and get everything fabricated and put together and tacked. The other thing that's really nice is that if you make a mistake and you need to fix it, you can break tacks apart pretty easily. A lot of times you can just break them with your hands. If not, get a little, maybe a hammer, or even if we had to just a quick light grind with a cutoff wheel and then snap them loose. Versus if you have a 5-inch weld, if you have this piece welded all the way across this edge and you decided that something was wrong there and you needed to fix that, you're not getting that apart. Or if you are, it's going to take you a lot of effort and a lot of work to get that weld off. So we tack everything we can and then weld pieces out. Okay? All right, so that's my spiel about tacking projects before we weld them. And I'm telling you, I've had students in the past go, it'll be fine. I'll just make these 3 pieces. I'll weld these 3 pieces together and I'll stick them to those 3 pieces. And when they come together, or they try to put them together, it doesn't work and they end up starting the project over. So rule number 1 in fabricating, tack the projects together. And this goes from this little design project you guys are doing in welding tech all the way to any project you ever built. You're going to build big, giant, long handrails. You're going to build a bridge. Obviously on a bridge, you have to hold sections and things. It changes a little bit, but we still set things in place, get them put together, held together with tabs, and then we weld everything out once we have everything fit up. Okay. All right. So that's my spiel on tack welding, and I'll demo this to you in just a minute. All right. The next thing we need to talk about, I'm going to move the camera down here. Sorry if it gets a little shaky, but the next thing we need to talk about is how to hold all of these pieces. So move my mouse out of the way. To hold these two, I'm going to start with these two. I'll start with my pentagon, and I'm going to want to get this piece tacked. Now, I don't want to tack it flat because then as I bend it, it's going to probably break my tacks. And depending on how I tack, I may not be able to bend it that much after I tack weld it. So I want to get it tacked up pretty close to where I want it to be. Okay. So what happens then is we need to be able to hold these pieces. So there's lots of different ways to hold pieces. And I brought in all kinds of clamps to show you different ways, styles using. These are 2 of my favorites. This is an F-style clamp. F-style clamps are really slick because it's really quick to get them to change shape because you slide this part down and then tighten it up here and it locks this thing in place. So if you had pieces that you wanted to clamp together or hold down, and you don't have to sit there and spin over and over and over, like for example, the C-clamp here, still a very good tool. But with the C-clamp, if I want to open this up to fit on this, I have to go wind this thing all the way out. And time is money. So this takes forever. And then by the time I get it all the way out, and then I can put it on here. And now I have to run it all the way back down, except versus this one, loosen up the clamp, slide up, it's off. If I had a thin piece that I wanted to clamp after, slide it down in place, tighten it up. So these F-style clamps are my personal favorite type of welding clamp that we use. Okay, and they come in different sizes. We have these are the small ones because it's a small project we're working on, but we have large ones as well. So different style of clamp. Okay, the other clamps that we use all the time in welding are these vice grip clamps. And these work really, really well. The same. These are made by Vice Grip, same as these, which also work well, especially for this little project that we're doing here. But you may have used these clamping pliers before. We call them Vice Grips. That's the industry name for them. That is the company Vice brand. If you buy them at Harbor Freight, they are not Vice Grips. They are trash. But anyway, sorry, I digress. Sorry, Harbor Freight, if you're watching this video. I shouldn't really be shot. I shouldn't be. They're not trash. They're just lower quality. I got to be careful, man. Okay, shouldn't be bad mouthing people on the YouTube. This is out there for everyone. But I do like the Vice Grip brand. Okay, they're a very good tool. You're going to pay a little bit more money for them. Just in case you've never used these, the way these operate is they have a clamp that locks. So right now these are locked. To get them apart, you can squeeze this lever that unlocks them and allows them to open. And then they're adjustable back here. You can see if I run this out, you'll see that how they're now a larger space here. So they won't clamp. They're not going to clamp the sheet metal, obviously. If I want to clamp the sheet metal, it's easier to spin the bolt in the back here, the adjustment, if they're unlocked. So we'll do that and then get it down. See, now it's smaller. We're going to keep going until it's all the way tight, ready to clamp the small piece. Okay. Now, if I squeeze a piece of metal, or here, let's do two, just so you get the idea that it is clamping these two together. Then you're going to squeeze really hard. Now, this one it can't quite close. That's because I have it adjusted too small. So I'm going to back it off just a little bit. And now it should, a little bit more. Now it should lock. And now the clamp is locked onto the part. Okay, it's clamping those two together. To get it loose, squeeze this part here and pop that a little bit ago. When they're tight, they're a little harder to get open, but there you go. Okay, so these ones work the same way. Nice thing about this style is it allows you to reach over parts. Also allows us to open them much further, right? We can clamp much larger parts. You couldn't use these ones to pick up this project, but this one I could, right? I can put this on here. I have to back it out a little more, but that would allow me then to clamp this one and have this one clamped. Okay. What we're more likely going to use these for, there's also this style. Kind of cool as well. This one allows you to clamp pieces together and still get in between them to put tack welds and things. These might come in really handy for some of you guys for your design projects, depending on what you're trying to do. So this is a good way to go as well. Other styles of clamps. These are not welding clamps, but life hack. You can use these for welding. I don't use them to hold pieces together to weld very often, but what they are nice for is, let's say that I wanted this piece right here to stand at a 90-degree angle. If I just clamped that, that's going to hold that up for me, which then would allow me to put this piece over here near it, and it frees up my hand so that I can then take the torch, and so it's holding one of my pieces, right? Kind of works as a third hand. So they actually come in pretty useful. What I love about these is these are cheap. Really inexpensive. This one's HDX. It's from Home Depot. Oh, I think this one is a Harbor Freight one. So see, I was bad mouthing Harbor Freight, but they have some great tools in there, and this is one of them. 99 cents. When you burn this up and make a mess with this, then I'm not. It is what it is. When it stops working, you throw it in the trash, or you recycle it. Actually, put it in the scrap steel bin, and then you buy a new one for 99 cents. Versus a nice pair of these, you're probably looking at $30-ish. So now these should last a lot longer than these, but you could buy 30 of these for one of these. So depending, obviously this does more, but this is a good tool that I imagine you guys will be able to utilize for these design projects to help you hold parts. And you don't always have to hold it at 90 either. Sometimes you might clamp, for instance here, I might take a piece of this, clamp it up at 90, and then that gives me something that I could lean another piece on. So if I wanted to put this piece on here to help me hold those, now it's holding that in the position where I might want to make that tack. Okay. So you're going to have to get creative on here. Holding your pieces together is going to take some creativity. So utilize your vice grips, utilize your spring clamps, utilize C-clamps, whatever you need to do to get these things in place. Another thing that I like to use is what we call a third hand, which is a custom-made helper tool, but I can't find those. I think they got misplaced when we moved back into the new shop we remodeled. So I don't know where those are right now. So what we're going to do instead of the third hand is just use some scrap metal. So I just got these out of the scrap barrel outside, and these can come in really handy to help you hold something. If you have, again, you can use it to lean something against. If you had a piece that you were trying to hold on here, you could maybe use it as a weight to hold that. So now I could put a tack there. So this is kind of like what the third hand does. It's just a weight that has a point that will hold things in place for you. So it allows you to do that. We could always use the buddy system as well. If you have a partner nearby, now you obviously got to be really careful when you're having a buddy help. When you have a lit torch, you want to be super cautious and safe that nobody's getting burned. But if you want to have somebody hold a piece for you, if this piece needed to be welded to that piece, you could have a buddy kind of hold this one in place for you, just like so. Hold it still while you put a little tack weld over here, keeping everybody's hands and things carefully away, but we can go about it that way as well. So be sure you're holding it with pliers, not your hands, but that's another good way to go. Okay. And another way that is really useful, and not the one it's not my first choice most of the time, but does work, is masking tape. So you guys put together your design projects in cardboard with masking tape. Masking tape works good for this too. You can hold small pieces of masking tape, put them on here, tack weld. Yes, they might burn up. Yes, they might catch on fire. That's okay. We're working with fire. We're not scared of fire. It's going to be okay if the tape burns up. What is a bummer about the tape, one of the reasons I don't like it as much, is because when it does melt, it leaves the goo behind. So your project will end up with some gooey junk on the outside. We can always clean that off later. But it is just an extra step that if we can get by without using that tape, then that's what we want to do. Okay. All right. So hopefully you guys will get a chance to experiment. The other thing I forgot to mention is this kind of scrap metal, but also anything that you need. Like this actually might be a pretty good angle. This might actually hold at a pretty decent angle for me to get this piece kind of where I want here. So look at that, right? I mean, that's actually going to be about the right angle. I think that's probably how I'm going to go ahead and tack this piece. It may not be exact because when I put this one up, say I can see, let's see, you guys can't see that angle. There you go. That's a little better angle. There is still a gap here. So this angle does need to be a little steeper, but that'd be enough to get it tacked and then bend it. All right. So let's go ahead and do that. Enough yapping about all this. Let me pause the video while I get my PPE on. And we'll get the torch fired up. I'm going to steal a torch from the booth behind me because I think filming out here is easier. I can't really film inside the booth very well. The lighting out here is better and gives me an opportunity to show you a little better what's going on, move the camera where I need to. So let me pause the video and I'll get suited up and show you the next part. All righty. Got my safety glasses on and proper welding attire. Got my gloves. Got my Lincoln Omni Shield. Shout out to Lincoln. I'm pretty impressed with these new face shields. I like them. So if you're watching Lincoln, send me some money and or some more some swag. Also, Lincoln fire retardant welding shirt. Very comfortable. Works great. Like it a lot. Okay, so you'll see what I got going here. A note, I did go grab a fire brick. Before when I was showing you, I was down on the table. Now these brand new Sigmund welding tables, I would not put this flame to these tables. And if I catch you doing that, I'll be very upset with you. So we got to keep these tables. These new fab tables are like dream come true stuff. So keep these in as good a shape as we can. Hopefully future videos on how to use these fixturing jig tables later. But anyway, for now, so you'll see I went and got the fire brick. Same thing goes in your booth. I'm not as worried about your table as I am the Sigmund tables here, but you also don't want all that heat generated. If I was trying to make this tack flat on the table, that table's going to steal all my heat. And remember, I'm trying to melt this piece here, so I need the pieces to heat up, not the table. So you need to get it up on a fire brick or up on, float it on some scrap metal or do something to get it up off the table, so that the table's not stealing all your heat. Okay. Now, I did do my little setup here, just like I showed you. I grabbed one of these old gas welds that somebody was practicing on. Just got that out of the barrel outside. So I like it where it's at right now to put my first tack on. So go ahead and get the torch lit up, and we'll sort of get this guy adjusted. Remember, we want to keep going until the black smoke's gone. I've never done this on the camera, so I don't know how well it's going to focus or what's going to happen, but we'll see what we come up with. Bring it down to neutral. Okay. And then to put this tack, I'm going to try to put a light tack on this corner right here. Okay, we'll get these two to join. And you are going to run into situations where you're going to have trouble getting these guys to join. So I'm going to show you how to deal with that in just a minute. We got those two joined. I'm going to flip this over and come this way. Actually, I think, yeah, we're good. Thought I bumped my valve there. You do want to be careful here. You'll see the flame is going to shoot off this brick and weird places. So you got to be cautious of what we're doing, right? Let me go ahead and turn this guy off now, and we'll take a look. I got the first one tacked. So this is going to be hot. It's going to be really hot. So at this point, it's time to use pliers, not gloves, right? You can bump things with gloves, but if you grab a hold of something and hold onto it tight, we're going to have an issue burning up the gloves. So here's my first one, and looks pretty good. You can see there. A little tack on that side, a little tack on that side. And so now I'm going to put my my next piece. Now, this is what I recommend that you do. I highly recommend that you kind of start in a corner and start working your way around. Sometimes I have students that want to build separate pieces together. Like say you were building a cube, and I'll have students that want to make like a C with one cube and a C with another, and then put them together and then weld that. I don't recommend that, because what happens is if either of those gets off a little bit, when you go to put them together, it can be really problematic. So I recommend starting with two pieces and just slowly working your way around logically which pieces are going to make the most sense to do next. So for my money, and for distortion reasons, I want to get the next piece on this edge or this edge, doesn't really matter which side, but I want to get that piece on there so that if I need to make adjustments, like you'll see right here, that I am going to need to make an adjustment because that angle is not steep enough, kind of like we already talked about a little bit. So what I'm going to do now is be able to adjust this one and make an adjustment to this one. And then I'll be able to keep going and working my way around, okay? Now this piece is cooled off a little bit. I'm also holding it down here at this end, away from where I had just tacked it. If I was to hold the small piece, it'd probably be a lot hotter. Also depends how long it takes you to tack it. So again, just be really cautious and careful here. So I need to bend this a little. And now that it's tacked, I should be able to bend it without breaking the tacks if I'm careful. Okay, there it goes. It's got a little steeper angle now. Do a little test fit, see how that looks. Still needs to go a little more. If it's too hot, use 2 pair of pliers, right? And bend it like this. Okay, you can do that as well, either way. That's getting close. You guys can't see, I'm looking at the opposite side. So that's close. I think I'm going to bend it just a little bit more, and then we're going to tack this piece on. That I like. Okay, that's a pretty good fit. I'm happy with that. Looks real good. Again, the fit up is going to be important. We really want to have a good fit up. So now it's actually going to be, now that I have these two pieces tacked, it's actually going to be a little easier to get this one because now I have another spot for this to tack. So what I'm going to do, set this up. And I haven't decided exactly how I want to hold this yet. Let's try a spring clamp and see if I can get it close. And all I really need right now is this corner up here to be a pretty good fit. And as long as I'm happy with that, I'm going to tack that. So to be a good fabricator, you're going to need some patience. I know for some of you that's going to be a struggle. Some of you are not very patient, but you're going to have to take your time now with the fit up, and you'll end up with a much better project. A little patience now will pay off dividends down the road as you keep going and putting this project together. So the only spot you guys can't really see, let me see if I can move the camera. Oh, this is a bad idea, but I'm going to do it anyway. The only spot that has a really good fit up is this corner right here. Okay. If you look down, you'll see the big gap right there between the pentagon and the trapezoid. I'm going to fix that after I tack this. I've got it real close right now. I'm going to put a little tack on that side, and then I'll fix it after that. Okay. That actually worked better than I thought. I thought for sure I'd lose my camera angle and we'd be a mess there, but not too bad. I'm a little off center now, which will bother some of you OCD people, myself included. So let's go there. Close enough. Whatever. I'm not going to get the millions if my production quality is poor. Too bad. You're going to get poor production quality. Also going to move my mouse because I don't want to burn up the mouse. Okay, let's put a tack here. Okay, and I'm just going to tack this corner where I have the good fit. See how easy that was? Torch off. Super easy to do there. Now, this piece down here is still cool. I didn't even weld or tack anything to it. I'm going to get my spring clamp off of there. Let me show you what I'm looking at. So I got a gap here that I need to fix, and I got a massive gap there that I want to fix. But with this just one corner tacked, I can make all those adjustments now. So I can take this, tweak that, and get that where I like it. And that looks pretty good right there. Okay. Now, I still have a little gap at that side. That's okay. I think I can make that work. That's totally fillable. I'll show you how we're going to address those. You guys are going to run into that situation. It wants to spring out when I let go of it. So this is where setting this thing up on a piece of metal or getting something underneath it and just putting some weight on it. Or if you can find a way to get a spring clamp on there or something to hold it, you can do that as well. This one might be a good, let's see, if I do this, put these two flat on the table, and I'll spin it this way so you can see. If I put these two, that side's hot. I just gotta be careful there, right? That side's warm. Don't do what I do, right? Do as I say, not as I do. I just touched the hot piece. That was stupid. I'm okay. I didn't get burned, but I felt the heat coming through there, and it made me realize I wasn't cooled off. So I'm going to squeeze this side down with a clamp on the table right here to hold that down. And lucky for me, with this fancy new table, I've got some special clamps just for this. Let me grab one. Oh, look at this fancy business. Yeah, that's right. We're moving up in the world here at Slow High. So we'll drop this guy right in here. That's going to hold that. And we'll just drop this down apply a little bit of pressure here until we get the fit we like. And that should hold everything in place for me. No. What am I saying no to? Yeah. Can I use the fixture table, Mr. Fay? Absolutely not. Not until you earn the right to do that. And until you've fabricated a project without this fancy fixture table, you don't get to use it. Because I'm 43 years old, 42. I'll be 43 next month. And this is the first time I've ever got to use these fixture tables. So, because I had to suffer through, so do you. And it's important to learn how to do this stuff without the ease use of these fixture tables. You'll get access to them when you come back and take metal 2, metal 3, metal 4. We'll see about using them in there a little more. But right now, you're still learning. You got to learn the right way. Okay, I'm going to put this tack here. And you'll notice now I don't have it on the fire brick. That's because it's up off the table. I'm going to get this corner joined. Little tack there. And that looks good. Now, this side I'm also going to tack, but let me pop my fancy Sigmund clamp off here. And this bad boy with some pliers. Okay. That's the one. This is the one I just tacked right there. Okay. Looks good. Now the other end of it, the other side of it here has a little bit of a gap still. So I'm not going to tack that just yet because I think I might be able to fix that tack a little bit. But now that I have these two edges, this thing stands up, should be pretty close to standing up all by itself. When I get this third edge on, it is going to stand up all by itself, which is going to make life pretty easy for me. So I'm going to take this one, and this is where I'm saying, as you guys work your way around, let's get ready to tack this one in place on here, like so. Okay, and then this thing will stand itself up. I have to turn it this way because the camera's on the opposite side of my eyeballs, but so I'm going to just put some pressure there. And again, you guys could do this with a third hand. Just put a piece of scrap metal on it. Here, I'll show you. I'm cheating using all my fancy new tools, but you guys could just take this piece, right, and just go like this. It's the same difference, and it costs thousands of dollars less. Obviously, this has way more capability than just that. But so my next piece, I'm going to line this guy up here, and now it's going to be even easier to get these things to line up. Okay, it wants to flop in. So this time, I tell you what, I'm just going to take another piece of scrap metal to position it where I want. See if that'll work, as opposed to a clamp. Look at that. That's money. Oh, you guys can't see here. I'll show you. Oh, yeah, buddy. I mean, that's just two pieces of scrap metal. No fancy, expensive, nothing needed. Okay. Solid. All right. I'm going to tack that one. And then I got to go start my class because the bell just rang and it's nutrition break right now. I'm filming this during first period of my prep. And I'll come back and finish this up later for you. Okay, but let me get these two tacked because this will make me happy. I like this. Oh, darn. Okay, all right. I see. It's because I got cocky. You see that? I started getting a little cocky. Tell you what I'm going to do. Because I got it pretty well supported there, I'm going to grab some pliers and hold it. Torch one hand. Pliers piece in the other. Okay. That one looks pretty good on that side. Little adjustment while the tack's still hot with the pliers. I'm going to tack. Actually, I'm going to wait on that corner because I might need to make a slight adjustment there. All right. But that's all I got for right now. I got to go start my next class. But I'll come back in a little bit and show you the rest. Okay, we'll get this guy all fabbed together today. And I might introduce some TIG welding as well, just to kind of give you a little precursor. We'll do some of this with gas because that's what you guys are going to do, but then I'll throw in a little TIG welding also. All right, see you soon. All right, folks. A little hiatus there because I had to teach classes all day, but now school's done. And so I'm going to pick up where I left off. I did tack one extra piece on there, just using the same techniques that we were using before. So I've got 4 of the 5 sides on our bottom half of our diamond. So what I wanted to talk about next, and this dawned on me today, is that students often ask about magnets. So I wanted to talk about them. I personally absolutely hate these magnets for a whole number of reasons, but their number one reason is that people start to rely on a magnet and think that a magnet is square or that it has something, some characteristic to it that does you a favor. For example, if somebody wanted to weld these 2 pieces at 90 degrees, I cannot tell you how many times, having taught welding for as many years as I have, both here and at Cuesta and Cal Poly, when somebody drops that there and sticks that there and thinks that that's square, ready to weld it, it's good. It's nowhere near square. It's not even close to being square. In fact, I don't know if I can prove it to you in this picture or not, but if we slide this up here, you could see that it is definitely, I don't know how well you can see that, but look at the gap at the top versus the gap at the bottom. It's nowhere near square, so that creates some issues. So that's the number one reason I hate them. Number 2 reason I hate them is because they trap and capture all kinds of garbage. Look at this thing. That's disgusting. Okay. And they just get rough, and they get just trashed with any grinding shavings, metal clippings, spatter, all that stuff. These things are just an absolute mess. Now, do they serve their purpose? Yeah, occasionally they do come in handy for certain very specific things. Okay. But the other major issue that I have with them, and by the way, on these ones that with all this spatter and all this junk, the next step up are these ones that you can actually turn on and off. These are much better. They're more expensive, but they do a much better job because they do tend to release the shavings and things. So like right now, it's got a magnet. It still has a magnet when it's in the off position, but once we lock this down, now it's a much tighter magnet. So these work a lot better. They do, though, still have their issues, and so you can still move them. But anyway, these are better. So if you are going to use magnets, I like these. The problem with what we're using these for here, gas welding, a couple of things. One, I've seen students just torch these things, and when these magnets burn and the paint on them burns, they smell really bad. Terrible, terrible smells. So that's yet another reason that I'm not a fan of them. But the biggest and most important reason that I don't like them is because now this piece that I'm trying to weld, I've introduced a magnetic field to it, and it's hard enough to control the puddle when I have complete control. Oh, what happened to my focus there? Man, we got a little out of focus. Let's see what we got here. There we go. Okay. I have complete control of the puddle. I'm trying to control the puddle. And when you add a magnetic field, now you get opposite magnetic poles, and it sends spatter out all over the place, and it just makes a giant mess. So I am not at all a fan of these magnets. Okay. Especially for this project, if we're doing with a gas weld. If we're just trying to put a little tack with a MIG weld or something, we can probably get away with it. For TIG welding, I never use magnets, but we'll get into that stuff later. And earlier I said I might try to get into some TIG welding. I've realized that we're fairly far into this video already, and I don't think we're going to have time to get into TIG welding on this one just yet, but we will hopefully in the future get a chance to introduce some of the TIG welding, because I need to finish getting this guy put together. Okay, so back to this guy. Here's an instance where a magnet might actually come in handy. I'm ready to put my last trapezoid on. So if I set this on here, it wants to slip. So this is a good example of where a magnet might actually come in handy, because I could use it. That's actually going to stay fairly close there, but I can use it not as a magnet on the piece that I'm actually going to weld, but just as a stop. So if I was to put this here, it can use it to kind of hold this piece directly so that it doesn't slide and fall, so that I have this fit up like this. Okay. Now you'll notice that the fit up here has a little bit of a gap. So I want to push the top down a little. And again, the best way to do that would probably be for you guys with just a C-clamp or a clamp in your booth. But since I have these nice clamps on this table, I'm going to go ahead and use one of these. And I'll just slide this down close. And I'm just going to apply a little bit of pressure here to add some force downward. And it's going to move my pieces around a little, so now I need to readjust my fit up. And I'm trying to, if I can, get every piece fit up corner to corner, just like we practiced when we were making these W's, right? Which, by the way, I'm going to take a minute to talk about these. I found this in the scrap bin. Somebody messed up a little bit of the weld right here on this side. So what? Why did you throw this away? This is a perfect piece to practice welding on. I would not have thrown this in the scrap bin. I would have put this in my locker if I was out of time, or I would have just welded it. You could make a really good weld across here and not weld up that part. That's fine. Okay, don't stress. You have one little mistake here and you throw the whole thing away. This is a massive waste of metal. We have to buy this stuff. It's expensive. So use these guys, right? You're practicing your outside corner welds, and we're practicing these outside corners specifically for this project. But that fit up, this one actually has a pretty good fit up. Nice little V-groove in there, and that's what we're looking for. Same thing on the project. It's going to be a little harder to get them. Here's another one that I found. You can see this one, the tack broke on the other side, so that's fine. But we could probably squeeze that guy back together with a clamp. Maybe even like just something simple like one of these spring clamps. Put that guy on there. Let that guy push together. Now put a tack up back on there and finish welding this one up, right? Let's utilize the metal the best we can. Same thing here. Here's 4 good pieces. Yeah, this half's probably toast, but this side's really good still. And we just went way too quick on these guys, but we could still come back and weld over these. I could do a practice weld over the top of this one. So anyways, just thought I'd mention that, throw that in. Utilize this metal as best you can, right? Okay, so this one looks pretty good. I really like the fit up on this corner. So I'm gonna tack that corner first. And then that should hold everything, and then I'll use my pliers to adjust and get that guy set where I want. So let me grab my torch here. Pretty good, sir. Let me pause this. Oh, sorry. All righty, we had a visit from Dr. Brewington there. I'll see if I can edit that out, but I'm not much of a video editor. Which is maybe why I'm not going to get a Lamborghini, because my YouTube production quality is not as high as it should be. But all right, so we'll get my neutral flame. Nice clean torch. Okay, and I'm going to heat up this corner. And since I like to fit up on all 3 pieces, I'm going to try to join all 3. So I'm kind of moving my heat around. There's 2 of them just joined to get the 3rd one joined in, and there we go. Okay, so that joined all 3 of these pieces on this corner. Now, I'm gonna show you in a minute about filler metal. And this is a piece of filler. And when you have a gap that you need to fix, this is a really good way to go about it. Or sometimes if you're having trouble tacking a piece, you can just dab a little filler metal in that corner. So you'll notice this corner right here, the fit up is not quite as good. And I put it on this side specifically for that reason. I'm going to get this magnet out of my way now though, because I don't want to burn it up. And it's got, this piece is now tacked and held in place. So I'm going to leave this Sigmund clamp on it because I think that it's pushing down on this part, which I want to maintain. But so I'm going to show you on this filler metal how to make this this tack and using filler metal. Now, here's the trick to filler metal. The torch doesn't melt the filler metal. The torch melts the base metal, and the base metal melts the filler metal. Meaning, I want to generate a puddle where I'm trying to weld, and then I'll dip the filler metal into that puddle. If you put the filler metal on here and try to melt it, it's going to look like a bird pooped on it. Terrible looking weld. You don't want the bird turd welds. It's going to have lack of fusion. It's going to be ugly. It's going to blob up and sit on top of the metal. Frozen butter, right? Sitting on top of the toast. So what we want is it melted all down in the butter so it's delicious every bite. And we want same thing here with our weld. So I'm going to melt a puddle on the base metal and then dip the filler metal into the base metal. So remember it that way, okay? Torch melts base metal melts filler metal. So it'll look like this. I'm going to hold this one here, and I'm going to get a puddle, and I'm going to keep the filler metal close, but not touching. And then as I start to get a puddle, then I can just dip that right into that puddle. I need a little more heat. There we go. And I'm just tapping it, a couple taps. And that added the filler metal to it, okay? Now, let me go ahead and shut the torch off. We can talk about that for a minute. Be sure that your filler metal is bent over on one end, right? So that you know which side is the hot side. This one's actually bent over a little bit wasteful. I would have probably preferred it to be found this one like so, but probably would have preferred to just like to kind of do enough, just about an inch or so, something a little closer to that so we're not wasting it. But that side, that end right there is really, really hot. So we want to make sure we know which side's the hot side and we're not grabbing a hold of it. But that way, what that allowed me to do is I had that little bit of space there, and it allowed me to fill that in pretty easily with just by dabbing a little filler. Might have been hard to tack that together without the filler. Okay. While I'm talking about the filler, this is looking pretty good. Let's come off our clamp here and see how we're looking. I think I like the way this looks. A little bit of a poor fit up here on this corner. I don't love that one. That's my least favorite corner. But I didn't tack that one yet on purpose because I'm thinking we might be able to adjust that. I might be able to do a little bit of work to this part right here. Okay, might be able to get. I think I'm actually going to maybe break that tack and let that piece spring out and then push this one in a little further. Or the other trick that we can possibly do is just tap it in with a hammer and it might move it just enough to make it fit. All right. But overall, that's okay. That's a pretty good fit up. I could weld with that fit up right there and be just fine. I'd probably have to add a little filler metal to it, but it'll work okay. All right. So while we're talking about the filler metal, I wanted to grab a piece, and I'm going to go ahead and take this one, and I'm going to try to do a little demo here, if I can, of how to weld a filler metal, a gap, in case you guys encounter a gap. And you're gonna, as you put these things together. Some of you will have more luck than others, but let's see. Let me get this up on the brick here and see if I can't get it a little closer to the camera. Okay. Now, I'm going to start, move this out of my way. I'm going to leave this gap. Now, I would pinch that hole closed just like I showed you guys. But I'm going to demo, if I have a gap like this, how to fill the gap with filler metal. You guys know by now, you've welded, that if you tried to weld this without any filler metal, you're just going to blow holes in it. So it's going to keep burning holes, which is what was happening to the student right here. Okay. So what we could do though, is I'll put a big tack on this side and then I'll spin this thing around, or I could just weld this way, I guess, doesn't matter. But what we're looking for when we're adding filler metal is we want the torch to be at the same 45-degree angle that we've been using, and we want the filler metal to also be at a 45-degree angle. So if we turned them, they'd be at 90 degrees to each other. And then, here's stupid magnet. See, this is why I don't like the magnet. Just grab my filler metal. Another reason why I'm not a fan of those. But so if this is 90 degrees, if I just rolled them both to 45, and the camera's picking up a little bit of a weird angle there because it's at an angle, but this is how I would add the filler metal. And again, I'm melting the base metal, and I'm just dipping this into the puddle. So if this hole right here is my puddle, I'm melting here, and as I'm doing my circle, as I circle back, I'm dipping the filler metal into the middle of the puddle and then circling forward. Dip, 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 right there. Dip, and kind of getting that technique going. Now, if I was TIG welding, I'd actually just feed this right into the leading edge of the puddle. But for gas welding, you want the filler metal to try to hit right into the center of the puddle. Okay, so let me give that a try right here, and I'll see if I can fill this gap up and weld this thing. We'll go along that. I'll go along that weld joint and see if we can't get that welded without squeezing it together, not using any extra clamps or anything, and just fix that gap. Because there's probably going to be some spots in your design project where you're not going to have a perfect fit. Now, you still want to take the time to try to get the fit as good as you can. Like I said, use your patience and do as best you can to get the fit, because don't just leave a big gap and go, it'll be fine, I'll just weld it up. The less of that you can do, the better. Okay, but this is what it will look like. So I'm bringing this up 45, and I don't know how well you can see that without a shade, but melt. So there's both edges melted. They're about to melt through, so I just dab that filler right in the puddle, and now I can just add filler right to the puddle. And now I've actually got enough control of the puddle. I don't really even need the filler here. The distortion in this case kind of helped me. It pulled the two pieces together, and this is looking pretty good. It's welding across there nicely. Okay, we'll get into this zone here where whoever welded this had those holes burned in it. Now I'm going to add some filler. Dab it in. Dab, dab. Giving it light little taps in there, and you let the puddle kind of dictate how much filler metal it wants to burn off of there. You just kind of tap it in there, and it just melts it in. You will get a few more sparks like you're seeing here. Okay. Some of you guys were having trouble at the end of your welds, burning holes in them. This is another way to help with that, because when you add the filler, you're cooling off the puddle. It's like adding an ice cube to a soda. It's kind of cooling it down as you add to it. So let me shut this guy off, and let's take a look at this one. So the weld quality is not going to be as good as it would be if we had a good fit up, but we fixed it. We got that piece welded. Probably going to have quite a bit of burn through. It does, because it had a gap. So whenever you have a gap, you're almost always going to have some burn through. But that's not too bad. I don't know if that focuses in or not. It's not great, but it would suffice, right? That would be enough. That would be enough weld on there to be able to complete the design project. Remember, this was in the scrap bin. Somebody had thrown this away as garbage. So now that's something that we'll be able to use. Okay. So that's your filler metal. And you may want to use that when you're tacking together parts on your project. So this guy here, if I wanted to put some tacks on here, like that one there where I have a little bit of a hole, I'd probably use a little filler maybe if I couldn't get it to work otherwise. All right, so now I'm going to make a few tweaks to this. Got a couple little zones here, little areas where I've got just a slight gap I don't love, but for the most part, it's pretty good. This one I liked the fit up, so I went ahead and put a tack on the bottom because it looked really good. That one, not too bad. That's not bad. That one's a little bit loose. For the most part, they all look pretty good. But those are going to translate now because I'm going to start tacking together my triangles. Okay. Now, to get this first triangle tacked, same problem we ran into before is once we get started, we're going to be in pretty good shape. So probably the easiest way to start would be to get two of these guys together. And so I think to do that, I'm actually going to try to just tack these two on their own first. And to do that, I think I'm going to employ a couple of our strategies we were talking about earlier, where I want those two pieces to kind of fit together really well. This might be a good spot to use our 90-degree fixture. I'm not going to keep these at 90, but if I just tack them lightly, I should be able to spread them apart a little bit more. So let me grab one of those fixtures. Okay, so here's this. I'm going to pick my better sides. Get these guys lined up carefully. And that actually looks pretty good. I like the way that it's touching on this end as well as on this end. So I'm going to put a little tack. I'm going to start at the top. I'm going to tack it there. When you have a pyramid like this, and I know several of you guys have pyramid-shaped designs, the pyramid actually allows you to, if you tack it at the point, it actually allows you to twist. Not only allows you to make some adjustments this way, up and down, butterfly, but also you can twist and rotate, move in and out, all of those kinds of things. So that's a good technique to use. But again, we want to try to get as close to the corner-to-corner fit-up as we can. So let's carefully set these in here and tack the point. Now I'm going to stand for this because the angle that I'm at, I'm sitting on the wrong side of the plate. You guys can do that as well, right? Got to get comfortable, whatever that's going to take to get comfortable. I also don't want to shoot a bunch of heat down at my table. I want the heat to go sideways. So bring this guy over here. A little tack here. And that's all I want. Don't want a lot yet because I want to be able to move these around. Now I might go ahead. I do like the fit up at the bottom here. I'm going to put a tiny tack here. If hopefully it's not too much to mess with a little bit, but okay, turn that off. Now that I have these two, this piece will stand on its own, which helps me out. The angle is obviously wrong because I'm not looking for 90. If you are, you're in luck, you have those little fixtures, but I'm looking for 60. So when I go to put this up here, that angle is going to be way too steep, but that's okay. Again, one of the reasons we just tack is that tacks allow us to bend. Now, they don't allow you to get crazy bending. I've had students in the past, it's getting close, a little bit more, one more. Okay, that's fairly close. We'll have to do a little bit of tweaking there, but we'll get that. So I have had students in the past that ask, can I just lay everything flat on the table and tack it and bend it up? Which is a noble idea, where they just want to do this, just tack everything and then bend it up. You may have done that with your masking tape when you were building your cardboard model. That's how I did my cardboard model. But masking tape is totally different than weld metal. So if you did this and tried to bend that, it would break, especially if you tried to bend it to a steep angle. If you only needed like 2 degrees or something, or 3 degrees, it'd probably get away with it. But if you're trying to take this from flat with tacks on the ends and you try to bend this up here, I would snap those tacks off. So you do have to at least get it somewhat close to the angle you're looking for and then go from there, okay? All right, now, so I want to get those two pieces lined up, and it's more important that I get one edge completely straight than that I get both edges. But I want to get close because that's going to set the angle of my bling bling here. So let's see how we're looking. And sometimes, if you need to, you can either wait for your pieces to cool or you can quench them. And that'll allow you, push these ones real quick. That'll then allow you to manipulate them with your hands. because they will be a lot easier if you need to do a lot of manipulation to the parts to use your hands on a nice cool piece. So I think this looks pretty decent. A little adjustment there. Not bad, but this is where the patience comes in. Try to get as good a fit up as we can. And these first two are going to be the hardest. Once we get these two set, then I think it'll be a lot easier. So I like right there. And this piece keeps trying to fall, so I'm actually going to bend it out a little more. So it'll hopefully keep it flat for me. Okay. Don't like it. So I don't like it. It's not staying close enough to where I want. So I think what I'm going to do is go this route. And like I said, this is going to make this a little sticky, but you want the tape. You don't want to go tons of tape. Don't tape all the way across these weld joints and then expect them to weld through that, right? So I'm going to put this on here and get that. I'm going to get just this corner right where I want it. Put the tape on there. And that's actually going to hold this edge. And that I actually like. I like the way this looks. So I've got a little bit of an issue here, so I need to bring this side up. A little more bend. This is where if you welded this entire pyramid together and tried to put the two halves together, welded the pyramid and welded the pentagon and tried to stick them together, you're going to have a hard time if they're not totally perfect. That's where they're going to get all messed up. So I like this. This is good. This is looking good. I'm happy with that. Let's get a tack on there before I bump it and do something to ruin it. Little bit of a gap there, but I like this side, so I'm going to tack this side. That'll get everything flowing for me. Okay. Little tack here. If I need filler metal, I can grab it, but I don't think I will for this corner. Like that a lot. Okay. That's all I want for this first one. Because now, see, you can see that I did, in fact, burn up the tape a little bit. That's okay. I want to take off the tape as much as I can right now. But this side right here looks pretty awesome. So before I do anything else, I'm going to go ahead and tack that side. I'm happy with that. This side's going to need a little adjustment. That might be a job for MC Hammer. You guys know that guy. Can't touch this. It's a good jam. I'll add that one to the Friday playlist. Okay, here we go. Tack this side. A little join there. I want to be careful about burning too much there because I got to also tack this other corner. I like this side as well. So I'm going to tack this corner right here. Oops, burned my pliers. Be careful of that. Got to watch your tools around you. Okay, those two are having trouble joining. There they went. But I was just about to grab the filler metal if they wouldn't have joined, but they did, so we're okay. All right, now I'm going to shut this off. And now this thing's getting pretty, it's getting pretty well tightened up. I have to be careful making too much of an adjustment. You see, this is the gap right here that I don't like. This side looks good. There you go. That side looks really good. Like that one. This one's got a little bit of a gap. I'm going to tap this one in with a hammer, but I have to be kind of cautious that before I do any hammering, I want to get a few more tacks on the rest of this project. So, so this time, I think this one is actually going to be much easier. This one right here, I'll try to do it facing you guys. This one's going to be much easier than the one we just did because now I have two sides that are solid that I can set this up against. I mean, you know, sometimes you just get lucky, and sometimes you're just good. I don't know. I think I'd rather be lucky than good. Is that how the saying goes? I'd rather be both. I'd rather be lucky and good. All right, here we go. I like this fit up on this side a lot, so I'm just going to put a little tack there. So those two joined, and I'm pretty happy with that fit up there. So I'm actually going to get some filler metal to join all four of those pieces at that corner. I'll do a circle with the torch to spread the heat out. Filler metal melts the base metal, or base metal melts the filler metal. So that side's good. I need to make a little bit of an adjustments to this side. But then I think we're done. I think we're there once this side looks good. Okay. Okay, that looks pretty darn good. I'm pretty happy with that. It does, when I move the bottom where I want it, it does actually separate this side a little bit. So you have to kind of consider which one would you rather deal with a poor fit up. If this is a big old gap versus a little gap over here, I'd rather have the little gap over here. However, if it makes a giant hole here and a giant hole here, you might have to split the difference. You might have to kind of go 50-50 in between them. But this looks pretty good. I'm pretty happy with where it's at right now. This side I could maybe come out just a little, but I want to tack the top corner, I think, instead first. So I'm going to do that. And I'm going to go ahead and pause the video and put the next one on so I'm not taking up so much time. And then I'll be back with you in just a moment. Okay, I've got that one tacked. Starting to look like a diamond. Okay. Now I've got this last one right here that I need to fill, and this one's going to be kind of like the first one. It's a little tricky because you have a hard time holding on to the sides of it. So a lot of times that last piece can also be tricky to put on. As I try to get this in position here where it goes, if I'm off on any of my other fit ups, this is where it's really going to show. And then when I try to put it in there, you see it slips inside and it's hard to hold on to that part. So then now it's all the way inside. So you're going to run into some of those issues with the last one. Couple techniques that you should definitely try to do is try a new position. Roll this thing around. This one has lots of facets. So get in a position where gravity might help you. Okay. Now, one thing to note is that if you do this, and I don't know how well you can see this, but I will have students sometimes that get these. I have a hole in my glove, and that's why anytime I touch anything warm, I need to get a new pair of gloves. I could feel it, and it's not burning me, but it scares me because I'm not used to feeling that heat because I have this hole in my glove. Bad idea. I'm going to get a new pair of gloves, but I don't have time to get one during the video here. Okay. Let me see if I can see how it's down inside there. That is pretty much impossible to fix. If you tack this in here and start welding this project together, you basically can't do anything about that. So that's something we do really want to try to avoid. Pieces dropped down inside. We can't do much with that. If it's the other way around, if it's sticking out the top, if it's kind of protruding like this, right, and it has a gap like that and it's up, we might be able to smash that down with a hammer and get that closed off, but we can't do anything once it's tacked in, welded in on the inside. So we do want to be careful and cautious about that. All right. So what I'm going to do is roll this around, and sorry, it's not to the camera side, but this is a little bit tricky to do here. So I think if I get that set in there just like so, and actually this might be another spot where some tape's going to help me because now that it's down there, I can't really adjust it. But if I have a piece of tape on it, I can probably get it adjusted a little easier. So let me go ahead and do that. Take my glove off so the tape stays sticky. Put a piece on here. That'll allow me to kind of hold the piece, right? Other ways to go about making something to hold on to would be to tack a piece to it, but okay, it just fell down in there. You can see it actually right here in the video. It fell down in there, so that's not good. I don't want that to happen, so I need to make sure that I fix that in whatever means necessary to do so. I think I need to reset my tape here. Put this tape on just a little more firm. And it may be a situation, this may be a situation where you get a buddy to help you. Because there are going to be those instances where it might be useful to have an extra set of hands, as long as you guys are being safe. You're using pliers to hold things, not fingers, so that nobody gets burned. I like to fit up okay on this corner, but I need it to come this way some. So I'll put a little tape on there and pull, and then tape that down. That's looking pretty good right there. Pretty happy with that. Okay, I'm going to tack this end, and then I need to make a little adjustment here, but it's close. So I'm going to tack the point here. I like it. Let's do it. Little filler metal. I got 3 of those 4 pieces tacked, but that 4th piece doesn't want to join, so I'm going to get a little filler metal to join them. Okay. And one up here on this corner. See, my tape's on fire. That's okay. Smells bad, but it's not going to hurt me. If I was being smart, I would have taken the tape off after I did my first 2 tacks, but okay. Now, sweet. This thing looks like a diamond. Okay. Now, though, is where students will ask me, how do I pick this thing up? How do I take it to quench it? I don't want to pick it up with my gloves. Get the tape off there now so I don't create any more goo. I want to make sure we throw this away because it does make a mess. How do I pick it up? Pliers won't hold it. Well, maybe. Might be able to get the end, but I'm most likely going to drop it. And at this point, with it tacked together, it's still very fragile. If you drop it, you're going to break it. So what I'm going to do, show you guys a little trick. You should, after people start using this filler, I don't have one nearby, but you'll eventually get to a point where you'll see people will weld this filler metal down, and all it will be left is a little bit that they were holding in their hand. So it'll look kind of like this. It's a little piece like this. You can find these in the scrap bin or in the trash can, somewhere like that. And what I like to do is actually, we're going to just weld this on to make a little handle so that we can actually pick this thing up to go quench it or do whatever we need to do with it. And it'll help. But this is actually a little bit longer than I want. I think I kind of want to, let me clip this. I'm actually just going to make a straight one. And then if we need to bend it later, we can. So enough that I can hold it without burning my fingers. But what I'm going to do is put it into the puddle and then remove the heat so that this little piece of welding rod actually welds directly to the project, and then I can pick it up and carry it with that. Now, some of you will have like a 1-inch area on your project that you can actually get a pair of pliers around, or a straight 2 flat edges that you could use. Some of the larger clamps, these clamps, F clamps, or you could use the big vice grips or whatever. But for those of us with shapes like this where they're not going to fit, here's the trick. Okay. You want to strategically place this little handle. If you are going to put one on, you want to strategically put it somewhere that it's not going to get in your way when you're trying to weld everything up, though. So let me heat the puddle here. There's a puddle, so I'm going to stick that guy in there and then remove the heat. Now it's got a handle that I can pick up with a pair of pliers. Here's my diamond. Okay. Now, keep in mind, if I go quench this right now, it's going to fill up with water, which is okay, but we do want to make sure that we get the water out of it. So if you quench it and dunk it in the water, hold it over the water tank and let it all drain out. All right. But this now allows me to kind of maneuver this piece around, and you can see that this guy is all tacked together. Okay, now, a couple things. First off, this is the second phase of this design project. This is what I want you to bring me for a grade. If it has welds on it, I'm actually going to mark it off because you're not supposed to weld yet, right? We talked about that at the beginning of this tutorial. You've got to tack everything up, right? When I make this weld down here, across this edge right here, this piece is going to try to pull towards the camera. And it can't now because it's tacked up here. And if this piece that was just tacked to this piece, it would pull both of them, but this piece is tacked to this one, which is also tacked to the pentagon, and they're all tacked to the pentagon. So that's how we're distributing those forces. We're making them fight against each other, and so it won't distort as bad. Now, where we have issues where it will distort is on these edges where you have a long length of weld. These pieces can bow in, get concave, or they can pop out and get convex. They'll actually start to kind of moon out on you. Or ramp in, right? So what we want to do to prevent that is put some tacks along these edges. What I recommend is you shouldn't ever really have more than about 3, maybe 4 inches max without a tack, okay? These pieces are 4 inches, and I think I can get across those without too much warping across that 4-inch piece. And I don't like welding over tacks because they mess up your rhythm and your flow of the weld. It's like welding over a speed bump. So I don't like to weld over them, so I don't want to put excessive tacks. But if I were to start welding this thing right now, I guarantee one of these larger triangles would either suck in or bow out, and I'd end up with a big old large gap along one of these edges right here. So what I want to do is put at least a tack in the middle, or 2 tacks. I think for the length this long, I think 1 would be just fine. Okay. So I'll drop a couple tacks on these and show you what I mean. I'll pause video and finish this up, and then I'll be back with you in a moment. Okay, so I have 4 of the 5 sides tacked. I have the last one to tack here. Now, you'll notice that this position that I'm in right here, if I was to tack this in this position, I'm actually now welding, that puddle's vertical, and it's much harder to weld vertical. That's the number 4 position, just a reminder. So I want to weld, if I can, always in the number 1 position, the flat position. So in this case, I can. If I just tilt this down like so, this is now flat. So now gravity's helping me, not hurting me. And so I'm able to put this tack in the middle of this one, okay? I've been using filler metal just to make sure that I don't burn a hole in my project at this point. So I'm gonna heat up here, both sides. I should see a little bit of puddle develop. And now I can just dip the filler metal into the molten puddle, and the filler metal melts the base metal. And I can do just like 2 or 3 little circles just to make sure I got a good solid tack. And I'll turn this guy off. Okay. All right. And this, once you have this guy all tacked up like so, looking pretty good. Oh, broke my handle off. That's okay. I can weld it back on. This is what I want you to bring me for your grade. Okay. Now, after you get it graded, after, key term, after. So after you get your grade on this, I will approve you to go ahead and finish to weld this out. So the final grade, so phase one was the cardboard. Phase 2 is cutting out all the pieces and tacking them together. Phase 3 is going to be to fully weld it out and then to finish it. So I'll probably either do another video on finishing, or I'll show you directly in class. But for welding, I want to jump ahead here a little bit and talk a little bit about it. So I've already talked quite a bit today about distortion. That's because distortion is a huge issue for us. So what's going to happen is if I come over here and I weld this, and then I turn around and I weld that, I just put tons and tons of heat into this one piece in this one side of this object. We don't want to do that. We want to move the heat around because now this side's glowing hot, and over here on this side, there's hardly no heat at all, or even down here underneath, there's like very, very little heat because that heat's not going to translate all the way over to these pieces. So what'll happen is this will start to cool very rapidly, much more rapidly than this side because it's already cool, right? So the metallurgical changes, the distortion is going to be greater if we dump a bunch of heat into one zone. So what we want to do is zigzag our welds. We want to kind of jump around. If you've ever learned to tighten lug nuts on a vehicle, it's the same idea. You have the wheel and you have a lug nut here. You don't just run that one all the way in and then run this one all the way in and then run that one all the way in because that could cause the wheel to get crooked, right? What do? You crisscross pattern. So you run this one in and then you jump opposite corner and you run that one in and then you jump over here to opposite side and you run that one in and then you run that one in. Same idea on the weld here. We're going to want to put like maybe a weld here, half of the weld up to the tack and then stop. And then maybe we flip and we go to a completely different part of the object. And if you knew exactly where it was pulling, you might weld the other side. But on a shape like this, it's fully enclosed. I just go to a different part. Maybe we weld across here. And then we flip from there. Maybe we roll over this way and maybe we weld the top edge over here. So now I'm distributing heat into these pieces. I had that one. Then I'll flip and roll and just pick a zigzag. Maybe go across here, weld that one up. Then we roll it and maybe roll again. Maybe we do this half now, bottom half. And then we'll flip up over here. Maybe we do this half here, etc. Just work your way around in a zigzag pattern to try to evenly distribute the heat throughout this as much as you can. Okay? All right, guys. I'm looking forward to seeing your guys' finished weld projects. I think this is a fun project. We've been doing these for years, and I love to see the shapes that you guys come up with. And when you have a finished product here, you get a nice thing to take home, and turns out to be kind of a fun one, right? So we'll talk a little more about after we get them welded. We'll talk about finishing using the grinders and how to do that, and then opportunities to maybe powder coat this thing and what we'd be looking at there. So that's all for now. Thanks for your attention. Video went a little longer than I had planned, but what can I say? I'm long-winded. Is what it is. And it takes some time to do these things, right? It takes a little patience, a little time, and but I'll be with you soon. If you haven't already, like and subscribe, and we'll see you next time.